My name is Robert Reilinger. I'm a principal research scientist at MIT.
Please describe your current work.
I use GPS to measure plate motions and deformation of continents, mostly in the Eastern Mediterranean area.
Does your current work relate to your work with the TI 4100?
Yes, my current work is very closely related to the early work we did with the TI 4100. I use GPS almost exclusively, a little bit of INSAR, but GPS is GPS. So yes, it's very closely related.
When did you work with the TI 4100? Year, month, day, multiple times?
I think my first work with the TI 4100 was in 1987, I think June. I remember because it was quite cold in Yellowstone. I was surprised we'd wake up in the morning to frozen water in June. I wasn't used to that. And the next, only other time I used the instrument was in Turkey, 1988, September, October. And we did training in Ankara, Turkey.
So did you train Turkish Geonosis?
We trained students from Hacettepe University. Our principal collaborator was a professor there, and he invited us to do the first GPS survey in Turkey. And we trained students mostly from Hacettepe, and we deployed 3 instruments, and each had one U.S. operator, either a UNAVCO engineer, an MIT student, and one Turkish operator. And we needed all our Turkish operators because virtually everyone got sick.
Oh. So GPS was brand new, and yet you were able to go into Turkey, which I don't know if they had the technology and the communications, or...
Yeah. Well, it was tricky to do. The logistics were very interesting in Turkey. No one had the technology anywhere. We had no GPS to find the points. There were no points. Yeah, so it was a new experience and very exciting. And you know, still to this day, you know, I have very fond memories of that early work.
And it was an international collaboration? Did the Turkish government provide some support too?
No, this was fully funded by NSF, thanks to the Mike Mayu, I think was the program manager at NSF, Geophysics. And the Turkish side didn't quite know about GPS at this point, and we had a little interview like this during our training session, and the authorities learned about our project we learned by the television news, and make a long story short, it took us 3 years to get the data out of the country because of concerns about security on mapping and positioning in Turkey in 1988.
And you were there to look at the North Anatolian fault? I mean, I assume it was because of a fault hazard and an earthquake hazard that...
Yeah, we were, well, the project was envisioned by my collaborator, Aykut Barka, the late Aykut Barka. He's a professor in Istanbul at the time. And he was very much interested in the earthquake hazard along the North Anatolian fault, and was quite an expert on the distribution of slip along the fault and earthquake activity. But we decided early on that we wanted to measure things on a much broader scale, that we wanted to measure the motion of the Anatolian region, the Anatolian plate, which of course is responsible for the accumulation of the strain on the fault. But we made that decision because, you know, we thought that's where we would do the best science. We'd learn the most about the Earth and geodynamics. And people had been making measurements across faults for 20 years with high precision. the Geological Survey with EDM measurements, Jim Savage's group. And we felt, certainly GPS has greatly expanded what we know about faulting and strain accumulation in the earthquake cycle. But we felt we could make a fundamental new contribution by understanding deformation on the scale of the interplate collision zone.
Okay, so you've answered those. Have you ever used an instrument or technique like this before? Before the TI 4100?
No, the TI 4100 was really absolutely new experience for me, and I'd never used any instrument except conventional leveling survey instruments and EDM instruments. So this was completely a new concept, and I was not sold initially that this was going to be the wave of the future. I said, wait, 1 centimeter maybe, if I'm lucky I can get a centimeter. I'd like to get a millimeter like I can do with my leveling. But a gentleman named Stick Ware, Randolph Ware, said, Rob, you better get on board. This is the future. And boy, that was the best advice I ever got. And he was absolutely right. Of course, now we're doing millimeter level positioning in 3 dimensions, and GPS has just revolutionized surveying of all kinds.
So how were you chosen to work with the instrument?
Well, I got involved, I'm trying to remember the gentleman's name. Well, early on I was working with conventional geodetic measurements, leveling primarily using the database of the National Geodetic Survey. And at that time there was a phenomenon called the Palmdale Bulge, and it was a bubbling up of the Earth's surface over a broad area in Southern California near the bend in the San Andreas Fault. It was discovered by Bob Castle and was defined by leveling observations, and I had worked in that area quite a bit. And well, we were very skeptical of the measurements because we had seen some very similar kinds of things in the Appalachians, for example. And we started questioning the reliability of this phenomenon. And make a long story short, over the course of a year or two, it was recognized that this was a result of an insidious error in leveling, which was really kind of curious. It had to do with shortening of the sight lengths between the leveling staves in Southern California because of the increasing pollution. So they couldn't see quite as far, so systematically, over time, they shortened these sight lengths, and the shorter sight lengths systematically affected the amount of refraction of the light along the line. So you got what looked like a systematic uplift of the mountain. It was really, and so having been involved in that, I was asked to, be involved in the early days of the formation of UNAVCO as this kind of skeptic who might help find the problems with this early system.
Who trained you to use the instrument, and what was the most difficult part of the training?
I received my training here at UNAVCO. James Stoll, who was one of the early engineers working here. I think he was the first employee hired by Stick Ware and Roger Billum, who started UNAVCO. And I believe he was a TI engineer who they coerced out of there and got to work with us here in Colorado. So he trained, I'd say, everyone who operated that instrument, and many people who operated many other instruments since. And he's quite an important member of our community early on in the development of UNAVCO.
And what was the most difficult part of the training?
Oh, James would make you roll the cables on infinitum. And if you didn't do it properly, you'd have to do it over again. I think he had some military background. And of course, we had very big, heavy cables. No, really, the training was, I mean, it was what the most difficult part was setting up a tripod precisely. And of course, it's the most important part of surveying with GPS, with any kind of surveying. But with GPS, that's probably the biggest source of error, is setting up improperly the tripod. So centering the instrument over the marker, measuring the height, it required the most finesse. Otherwise, it's pushing buttons.
What was the most exciting part about using the instrument?
Let's see, what's exciting about using an instrument? I'd say the places that we went, going places in style, you know, GPS. I think that's the most exciting thing. I don't know. I mean, I'm not a gadget guy. I'm not excited by instruments. I'm excited by science. And the science that we have been able to do with that instrument, with not that instrument, but with GPS, that's what excites me.
Well, so would you want to go back and do leveling the way you were doing it, or do you think the GPS was easier?
Oh, well, no. Yeah, leveling is, you know, incredibly difficult, time-consuming process, and it's not something that we even did. We just did it so we'd have some understanding of the technique, but it takes, you know, a whole leveling crew, and it's very expensive, and you can do, it's very, very limited what you can do. No, GPS has taken over, and I'm very, very happy for that.
What was the biggest benefit of using the instrument?
The biggest benefit was just learning how to do surveying. The fact is how to run GPS campaigns, how to work internationally, how to develop international collaborations, and do the logistics in these different places where we wound up, you know, really doing some work over the next 20 years. The data is no longer used. It's been superseded by just so much better, so much more precise positioning. And it's not only it's not the instrument as much as it is probably and partly the instrument design and antenna and tracking system, but also the global network. There just was no tracking network, so we had very poor resolution of the satellite position. And if you don't know where the satellite is, it's very hard to know where you are.
How many satellites were in space at the time of the TI-41?
Let's see, when we started, how many satellites were there in space when we started in 1988? I will have to look back, and it's all there, documented. All I can tell you is we could only track a few anyway at a time. I think 4, if I'm not mistaken. And I may be wrong. And I know that we could only track for 8 hours. And we'd have to pick the correct 8 hours that we'd have enough satellites in the sky to be able to get some kind of reasonable positioning.
Did you leave your mark on the instrument?
Nope. I didn't leave any mark on the instrument that I know of.
You didn't drop it?
No, I don't think so. And I didn't even get to sign the antenna in the UNAVCO case over there. No, I don't think I left any mark on the instrument. I didn't give any advice as to how, you know, they could improve it. And the engineers who were working with the instrument had that covered. I did have one experience with the instrument that I didn't mention, and that was with what was called a sort of testing of the instrument in the Air Force Geophysics Laboratory. I don't remember when, but it was a test of a micrometer, which is another instrument that was built by MIT, and the TI, and the idea was to run them simultaneously and do a comparison of the position. And a really nice young man from TI came up and ran the instrument. And all I can tell you is it was incredibly competitive. That there was in this time development of this instrument, it was recognized by everyone that this was an important development, and that there was a lot of science and a lot of money involved So there was a tremendous amount of competition in building this instrument, and even in the scientific community.
Did the instrument leave a mark on you?
Well, it got me hooked. I've been doing GPS ever since, so I guess the answer is yes. The instrument absolutely got me started in GPS, I had a Russian colleague who gave a talk at AGU a year or two ago, no, some years ago, Mikhail Prilepin, great gentleman, geodesist. And he stood up in front of the audience and he said, well, I used to be a classical geodesist, and then Rob Reilinger turned me into a GPS man. And I have to tell you, it was one of the greatest moments in my professional life. I felt very proud, and it was a nice moment at an AGU meeting. So,
do you have a fond memory about the instruments to share?
Well, there's one right there. That's one fond memory. Well, the other one memory was we had a group when we had the instrument in Turkey. We had a group from the design department in Hacettepe University make a symbol for the road to Hacettepe. James Stowell came up with that name, and we used the TI antenna as the emblem, where we put it in a perspective, so it was like a minaret in a Turkish mosque.
And did the Turkish appreciate that?
Yeah, I think so. I think very much.
How did the instrument contribute to advancing your work?
The most important aspect was just getting us going on GPS, learning how to do surveying, learning how to run the logistics of a survey in difficult, sometimes difficult conditions.
Have you used more modern instruments for the same or similar work, and how have the instruments changed?
Holy moly, yes, I've used the more modern instruments, and there's, of course, no comparison. The precision is an order of magnitude better. The power is very low. We had constant power failures. Trying to maintain battery power for the instrument was, you could guarantee certain data loss due to power failures. The instrument weighs next to nothing. You can carry it up the hill and manage to make your GPS station where you absolutely want it. You can measure for 24 hours and get 2mm positioning. So yeah, this is, the improvements are tremendous, and of course as a result of the proliferation of GPS in so many areas of our modern life.
Any other comments about the instrument that you'd like to share?
I think I'm done. I don't know. Nothing else I can think of. No other comments, and just a great contribution to our work, and a technology that is not going anywhere. We're going to be using GPS for our kind of work, geodynamics, for a long time. I mean, we'd like to be able to use satellites to measure everything and not have to go in the field, but that's not going to happen. So yeah, I feel very fortunate to have been involved in this work, just been around at the right time in the right place, and gotten to measure things no one ever measured before. And that's what earth science, that's what leads to new understanding in earth science. So it's been a great opportunity for me.